Now let's talk about radicals and complex numbers. So in here, we will learn how to add, subtract, multiply, rationalize, and simplify expressions using complex numbers. So to work with the square root of negative numbers, mathematicians have defined what are called imaginary and complex numbers. So let's define what an imaginary number is. So from the definition of imaginary numbers, and imaginary number is denoted as I. So I squared is just equal to -1. Thus, I is just equal to the square root of -1. So examples of imaginary numbers include 3i, -6i, 3/4 I, or 3i square root of 7. So a complex number is one that contains both a real and imaginary part. So when we say complex, okay, it contains both a real and imaginary part. Let's say, for example, 2 plus 7i. So this is our real number, and this one is the imaginary part of the number. So with this definition, the square root of a negative number is no longer undefined. So we are now allowed to do basic operations with the square root of negatives. First, we will consider exponents on imaginary numbers, and we will do this by manipulating our definition of I squared equals -1. So if we multiply both sides of the definition by I, say this is our definition of imaginary numbers, I squared equals -1. If we multiply both sides of the definition by I, then this equation would become I cubed equals -1. So if we multiply this by I, then if we multiply both sides again of this equation, this one by I, then this would become I to the 4th equals -I squared, but I squared is just equal to -1, so this is equal to the negative of -1, which is just equal to 1. Therefore, I to the 4th is just equal to 1. So multiplying again by I gives, okay, we multiply this by I, this gives I to the 5th equals I. And one more time, we multiply again this expression here by I, then we get I to the 6th, I squared, which is just equal to -1. So I to the 6th is equal to -1. And if this pattern continues, we see a cycle forming, and the exponents on I change, and then we cycle through simplified answers of I. The cycle goes like this: I, -1, -I, and 1. As there are 4 different possible answers in this cycle, if we divide the exponent by 4 and consider the remainder, then we can simplify an exponent on I by learning these values, 4 values here. So we call this as the cyclic property of powers of I. Let me write that down. Cyclic property of powers of I. So we can write that as I to the 0 is 1. We can start with 1 because any number or any variable raised to the power of 0 is just equal to 1. And then I is just equal to I. Then I squared is just equal to -1. And then I cubed is just equal to -I. So let's try solving some problems here. Let's say we're given I to the 35th. our exponent here is 35. So by using the cycle property of I, we can divide the exponent here by 4. So we divide 35 by 4. Since 35 isn't divisible by 4, so we will be left with a remainder. So if we're going to divide 35 by 4, we can only divide the 32 there, because 32 is divisible by 4. So this would result to 8, and our remainder is 3. Okay, so we can use the remainder as an exponent for our I here. So I to the power of 35 can be simplified to I cubed. So we just use the remainder as our final exponent of our imaginary number. So I cubed is just simply equal to negative I. So I to the 35th is just equal to negative I. So let's try another one. So what if we're given I to the 124th? So let's divide 124 by 4, and 124 is divisible by 4. So we don't have any remainder here. So that means our remainder is 0. So let's try dividing 124 by 4. So that is equal to 31. Exactly 31 without a remainder. So our remainder is 0. Since our remainder is 0, then we will use that remainder as an exponent on I. Therefore, I to the 124th is just equal to I to the 0, and which is just equal to 1. So when performing operations, addition, subtraction, multiplication, or division, we can handle I just like we handle any other variable. So this means when adding and subtracting complex numbers, we simply add or combine like terms, like we do with those expressions with only variables, numbers and variables without imaginary numbers. So let's try adding some complex numbers here. So let's say we're given 2 plus 5i plus 4 minus 7i. Okay, it is important to notice what operation we are doing, because some students see the parentheses and think that that means FOIL. That means we multiply, but we only use FOIL method to multiply. So this problem here is an addition problem, so we simply add terms or combine like terms here. So we can remove the parentheses here, around brackets. So we can write this as 2 plus 5i plus 4 minus 7i, and then we group like terms. So 5i goes with 7i, and then 2 and 4. So 2 plus 4, that one is 6, and 5i minus 7i is just negative 2i. So the solution to that problem is just equal to 6 minus 2i. For subtraction problems, the idea is the same. We just need to remember to first distribute the negative onto all the terms in the parentheses. Say, for example, we're given 4 minus 8i minus 3 minus 5i. So in this case, we just have to distribute the negative, since our operator sign is minus. So we distribute negative here, because negative here is just considered as negative 1. So we can write the whole expression as 4 minus 8i. Negative 1 times 3, that would be negative 3. Negative 1 times negative 5i will be positive 5i. And then we combine like terms. So 4 minus 3, that is equal to 1. Negative 8i plus 5i, that is negative 3i. Therefore, this expression here is just equal to 1 minus 3i. How about if addition and subtraction are combined into one problem? So let's say we're given 5i minus 3 plus 8i plus negative 4 plus 7i. Okay, so we distribute all the negatives first, and then we can combine like terms. So we can write this expression as 5i, and then we distribute negative here. Negative 1 times 3, that is negative 3. Negative times 8i, that is negative 8i. Negative 4 plus 7i. And then we group like terms. So negative 3 minus 4, that is negative 7, and 5i minus 8i, that is negative 3i plus 7i, so that is 4i. So this expression here is equivalent to negative 7 plus 4i. So multiplying with complex numbers is the same as multiplying with variables, with one exception. We will want to simplify our final answer so there are no exponents on I. Let's say, for example, whatever given 3i times 7i. So we just have to multiply the coefficients and the i's here. So we multiply 3 times 7, that is 21, and then I times I, that is I squared. And I squared is just equal to negative 1. Therefore, this expression would be equivalent to 21 times negative 1, which is just equal to negative 21. So let's try another one. What if we're given 5i times 3i minus 7? So we just have to distribute 5i. So 5i times 3i, that will be 15i squared minus 5i times 7, that is 35i. So we can simplify I squared here. 15 times negative 1, because I squared is just equal to negative 1, minus 35i. Then we multiply the negative. This would be negative 15 minus 35i. So that is the solution to that problem. Okay, well, let's try some more problems here. So what if we're given 2 minus 4i times 3 plus 5i? So in this case, we can use the FOIL method. So we multiply the first two terms first. So that is 2 times 3, so that is 6. And then the outside terms, 2 times 5i, that is plus 10i. And then the inside terms, so be negative 4i times 3, that is negative 12i. And then the last terms would be negative 4i times 5i, that is negative 20i squared. Then we simplify I squared, because our I squared is just equal to negative 1. So that is 6 plus 10i minus 12i minus 20 times negative 1. Then we further simplify this one, and we combine like terms. 10i goes with 12i, and then this one, negative 20 times negative 1, that would become positive 20. So this is 6 plus 10i minus 12i plus 20. So 6 plus 20, that is 26, and 10i minus 12i, that is negative 2i. So this one here is just equivalent to 26 minus 2i. Okay, what if we're given this problem? Okay, so we have 3i times 6i times 2 minus 3i. So we multiply first the two monomials here. So we have 3i and 6i, so that is 3 times 6 is 18 times 18i squared times 2 minus 3i, and then we distribute 18i squared to 2 minus 3i. So we have 18 times 2, that is 36i squared minus 54i cubed. And then we simplify from the cyclic property of I, which we previously discussed. So I squared is just equal to negative 1, and I cubed is just equal to negative I. So this would become 36 times negative 1 minus 54 times, this is negative I, okay, negative I. Then this would be equal to negative 36 plus 54i. So this is our solution. So you have to take note of that when multiplying complex numbers. So dividing with complex numbers also is one thing we need to be careful of. If I is equal to square root of negative 1 and it is in the denominator of a fraction, then we have a radical in the denominator, which isn't allowed. So this means we will want to rationalize our denominator so there are no i's. This is done the same way we rationalize denominators with square roots. Say for example, we divide 7 plus 3i over negative 5i. So I here, since I is equal to the square root of negative 1, so it's considered a radical, and we shouldn't leave a radical in our denominator. So we just have to rationalize this, meaning we multiply both our numerator and denominator by I. So we multiply this I and I. Okay, so this would become, we distribute I to 7 plus 3i. This would, we can write this as this one, and negative 5i times I. So this would just be equal to 7i plus 3i squared minus 5i squared, and then we can simplify this. Since I squared is just equal to negative 1, so this would be 7i plus 3 times negative 1 over negative 5 times negative 1. So this is just equal to 7i minus 3 over 5. So this is the solution to this one. Okay, let's try another problem. Okay. What if we're given a binomial in the denominator? A problem that has a binomial in the denominator. Let's say we are given 2 minus 6i over 4 plus 8i. So our denominator here contains is a binomial. So we just have to multiply the conjugate. Okay, conjugate of the denominator. So since our denominator here is 4 plus 8i, then we multiply by the conjugate of this, which is 4 minus 8i. Okay, so this is 4 minus 8i over 4 minus 8i. Okay, so we do FOIL in the both the numerator and the denominator. So we can multiply 2 minus 6i times 4 minus 8i over 4 plus 8i times 4 minus 8i. We can do FOIL here. Okay, so 2 times 4, that is 8. 2 times negative 8i, that would be negative 16i, and then negative 24i, then plus 48i squared, and this is equal to 16 minus 64i squared. And then simplifying the I squared, because our I squared is just equal to negative 1. So this would become 8 minus 16i minus 24i plus 48 times negative 1 over 16 minus 64 times negative 1, and then simplifying this further by combining like terms. So this would become, okay, 48 times negative 1, that would be negative 48. And 16i goes with 24i. So that is 8 minus 48, so that is negative 40. Negative 16 minus 24, that is negative 40i. And then our denominator, that is 16 plus 64, so that is 80. And then we can further simplify this by dividing both our numerator and denominator by 40. So we can divide this by 40 because they are both divisible by 40. So we can simplify this as negative 1 minus I over 2. So this expression here is just equal to negative 1 minus I over 2. So using I, we can simplify radicals with negatives under the root. And we will use the product rule and simplify the negative as a factor of negative 1. So let's say, for example, we're given square root of negative 16. So how are we going to simplify that? Okay. Simply, we consider the negative as a factor of negative 1. So we can write square root of negative 16 as the square root of negative 1 times 16. Then square root of negative 1, or we can just simply write this as square root of negative 1 times square root of 16. And we know that square root of negative 1 is just equal to I, and square root of 16 is equal to 4. Therefore, square root of negative 16 is just equal to 4i. Okay, let's try another example. But if we're given square root of negative 24, so we can write this as negative 1 times 24, or simply we can separate the radicals to square root of negative 1 times square root of 24. Okay, so square root of negative 1 is just equal to I, and square root of 24, we can write 24 as 4 times 6, and square root of 4 is just 2, so we can write this as 2i square root of 6. So that is our solution. So what if we're given another problem, this problem here? Okay, square root of 6, negative 6 times, say, square root of negative 6 times square root of negative 3. So how are we going to solve that? We just simplify the negatives first, so bringing I out of radicals. So we can write this as negative 1 times 6 times square root of negative 1 times 3. So we bring out I out of radicals, so this would just be equal to I square root of 6 times I square root of 3. And I times I is just I squared. What's that? I squared. Then square root of 6 times square root of 3 is just equal to square root of 18. So that is I squared is just equal to negative 1, and square root of 18 can be written as square root of 9 times 2. So that is negative 1 times 3 square root of 2. Therefore, this expression is just equal to negative 3 square root of 2. So let's try one more problem here. Okay, what if we're given negative 15 minus square root of negative 200 over 20? So if there are fractions, we just need to make sure to reduce each term by the same number. Okay, and we can learn how to do that in this example here. So we just have to simplify the radical first. We find the perfect square factors, including negative 1. So for negative a square root of negative 200, we can write, okay, square root of negative 200, we can write this as square root of negative 1 times 100 times 2. And then we can extract square root of negative 1, which is just equal to I, and then square root of 100 is 10. So square root of negative 200 is just equal to 10I square root of 2. Then we can plug this into back to our original equation. So this would become negative 15 minus 10I square root of 2 over 20. Then since all the factors here are divisible by 5, so we can divide both our numerator and denominator by 5. So this would become negative 3 minus 2I square root of 2 over 4. So that is our solution for this problem.